The last lesson of the day was derivatives of trig functions. So what this will do is just review the product and quotient rules, and it will also have the special context of trig functions themselves. Okay? Anne, ready? Yes, okay. Sorry, I have ADD, you need to pay attention to me. Okay, so here is the graph of sine. I want you to use it to sketch a graph of its derivative, which we don't know what its equation is yet, okay? So when you're sketching graphs of derivatives, the easiest thing, to find is where the slope is 0. So how many places on my picture is the slope 0? 4, and probably also these endpoints there too, right? You see that? Okay, so slope 0, slope 0, slope 0, slope 0, slope 0, slope 0. Okay. And then from here to here, what are my slopes? Positive or negative? Positive. And does it make sense that they look to be the biggest positive number in the middle? Like if you think about that slope versus like this slope, do you see what I mean? That this is steeper than that, right? Steeper means bigger slope, right? So you have a derivative being 0 over here, 0 over there. Your picture's going to go something like this. And this is my bad drawing skills that are kind of causing us issues here. But this slope is, oh, that was the, okay, well, that was because I was on the, what's it called? This is only supposed to go up to 1. Anyway, that was the highlighter function, which I was not intending to use. What happens on the next bit? Goes down. So negative slope has to go back up through that 0. What happens from here to here? Goes up. Okay, how about from there to there? It is. Goes down and then does this. Goes back up. What function does that look like? I'll sketch it a little bit darker and all in one color.
Isn't that the sine of x?
Sine of x is the original function. The one that I'm drawing in blue is, yes, it is cosine of x. Yep. So if y is equal to sine x, y prime is equal to cosine x. The technical way to prove that is take the limit as h goes to 0, sine x plus h minus sine x over h, and doing so involves a tricky trig identities and then knowing how a specific limit works. Like that's the way you prove it, and you can prove that this equals cosine, but I think that the picture should give you enough suspicions that that's probably true. Also, I can kind of explain why the slope is a little biggest in the middle. So I always think about length of day in Alaska as a sine function because it does go up and go down in a predictable cycle, right? If that is my cycle, this is the lowest, this is the highest. This is the day of the lowest light. So the least light, does that make sense? So least light, highest light. This point right there, that's when the light is equal, like equal day, equal nights, the equinoxes. No, yeah, the equinoxes. So when it's like super, super dark, how fast do we gain light at that point in time? Like on that shortest day of the year, we don't gain light very quickly, right? It's like 20 seconds per day, right? How fast are we gaining light in the middle? It's like 6 minutes per day, right? The slope is about 0 there and biggest in the middle. And when we get to the longest day, we don't lose very much right away. Like initially we just lose like 20 seconds per day, and then it starts to get faster and faster and faster. So that's like what our light cycles are like. So the derivative of sine is cosine. That's a formula you're gonna have to remember. The picture is one reason to believe that it's true. And that was, I think, a homework question I gave you, right? Yeah. Okay, so let's do the same thing with cosine. So the derivative will be 0 here, 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 and here. Okay. Now until this first 0 is the graph of the derivative above or below the x-axis. Slope is positive, therefore above. So above, slope is negative, therefore below. Positive slope puts it above again, right? Negative puts it below. Above, below, okay. Okay, so here's the derivative. Pick a,
You say that the derivative of cosine is negative sign because we started at the origin?
well, the technical reason is that you have to use that limit definition and prove it, right? I mean, that's really the reason. The reason I'm giving you is from this picture, what does it look like the derivative of cosine is? Looks like the derivative is, like you said, it's negative sign. Okay, so that is we're going to use that formula to do other stuff today, but the picture is the reason that you have to believe me that this is true.
Because if I wasn't looking at the origin, I'd have no idea.
And that's what you should look at. You should look at the origin. Like this is an oscillating function, right? It goes through the origin, and sine is that oscillating function, like one of them that goes through the origin, right? It has the right shape of sine, except for it's just like it's been reflected over the x-axis. Okay, so that's the reason you should believe those two formulas, is from the pictures.
And seeing one that starts with a C is a negative, right?
Yeah, there is that pattern, and I'll say that as soon as I get to it, okay? But yes, you are right. Okay, once you know sine and cosine's derivatives, every other derivative can be computed using the quotient rule, okay? Because what is tangent? Sine over cosine. So if I want you to find y prime or tan prime, you can take the fact that tangent is sine over cosine and use the quotient rule and figure out what its derivative is. Okay? So the quotient rule, we do low d high minus high d low all over low squared. I put my prime signs there because I didn't do derivatives yet.
Did you say the denominator is 1 plus sine squared?
You could, but I don't think that's helpful, okay?
Okay, I'm just curious. No.
But you could, yes, you could say the denominator is, and I think it would be 1 minus sine squared.
Okay, something like that.
Yep. Okay, what is the derivative of sine? Cosine, so we got cosine x, so can I just say cosine squared x? Okay, minus sine times negative sine,
So that's just plus sine squared of x.
it's just plus sine squared of x. Okay, and can you simplify cosine squared plus sine squared?
It's 1.
1. And then what would 1 over cosine squared x be? I think it's just 1 over cosine is secant, so it is secant squared. But you see how that came from all of sine and cosine's derivative plus quotient rule?
Yeah.
So you don't have to ever prove that again unless I ask you to do it explicitly. The derivative of tangent is secant squared x. Like you're just going to know that rule and you can use that rule. There will be a lot of formulas in this chapter. I would suggest making flashcards and adding them as you get them, because you're just gonna have to know them. Okay, and how do you think you would do cotangent? It's pretty much the same way. It's just cosine over sine, right? If you flip it. So I might ask you to do that on a quiz and say, prove the derivative of cotangent is blah, and you just like use the same idea. A negative cosecant squared. It's almost the exact same thing. Yep. Okay, and let's do cosecant. So cosecant, so make it sines and cosines. So it is 1 over sine x. Okay. So y prime will be cosecant's derivative, which will be low. D high, what's the derivative of that 1? 0. Yep, you're not wrong, it is 0. Minus high d low, derivative of sine is cosine, all over sine squared, right? So that's negative cosine x over sine squared x. You okay with that? Okay. Most of the time, here's what people do with this. They make it into negative cosine over sine times 1 over sine. Does that make sense that that's the same thing? What's cosine over sine? And 1 over sine is cosecant. So the derivative of cosecant x is negative cotangent x cosecant x. Or negative cosecant cotangent, yes.
Why did you times the 1 over sine?
Why did I times the, so for you're talking about from here to here? So I wanted to write that function like a little bit more simply with identity. And so I know that sine squared is sine times sine. So it's kind of like the stuff you might have done in a trig class where it said prove that this thing equals that thing, and you had to like fill in the steps in the middle if you took a trig class. And so what it is to show that this is the same as this, you just say, okay, sine squared is sine times sine, so fractions working multiply numerator times numerator, denominator, right? So it's just more common to give the derivative as negative cotangent cosecant. I think I almost always even say negative cosecant x cotangent x, but that's the same thing, right? That's a t, not 2 x's, but. Okay. What I'll probably do on your quiz is there are 6 trig functions you've got to know the derivatives of. Question on there. Well, maybe not. Maybe I'll make sure every single trig function is in a question. Ha. So derivative of sine is cosine. Derivative of cosine is tangent's derivative was,
Secant squared x.
and cosecant's was negative cosecant x cotangent x. The last 2 I will tell you because you prove them the exact same way. Secant's derivative is secant tan, and cotangent's derivative is negative cosecant squared x. All the co-functions have negative derivatives. Do you see that pattern? I didn't actually see it until a student pointed it out to me. What do they mean? What do I mean by co-functions? Cosine, cotangent, cosecant, right? So all of the co-functions have negative derivatives. Also notice that tangent and cotangent are kind of similar, right? Because they're reciprocals of each other. Secant squared, cosecant squared. You see which is the other reciprocal function squared from one to the next? So if you know tangent is secant, you know cosecant is the other one, right? And plus is negative. And aren't these 2 kind of similar also? You see what I mean? They both involve themselves, right? And either tangent or cotangent. Do you see what I mean? So you can see that there's patterns that are going on there. Plus all the cos have negative derivatives. Does that make sense?
They all come from the same triangle.
They'll come from the same triangle, yes. They're relationships. Okay, so find the derivatives of these functions. So if g of t is 4 secant t tan t, what is g prime? 4, what's the derivative? Do you need any funny rules here?
No.
No. So what's the derivative of secant?
Secant x, tan x.
So secant t tan t plus derivative tangent would be,
Secant squared t.
and I'm going to have you take out your greatest common factors, at least in class and on your quizzes as well. So what is the greatest common factor here?
Secant?
secant t, times 4 tan t plus secant t. Is that all right? Okay. What rule will you have to use on this guy? Product rule, yep. So y prime will be, first differentiate x squared, you get 2x. Leave the sign alone. Now leave the x squared alone, differentiate the sign, and you get cosine. And if I said take out greatest common factors, what are they? Just x. X times 2 sine x plus x cosine x. It just gives you some more interesting things you can do product rule with, right? And there are certain functions for which these things apply, so there are certain situations. Okay. How about this one? What rule do you have to use?
I'll say quotient.
Quotient rule, yep. So low d high, what's the derivative of 1 plus sine? 0 plus cosine, so can I just say cosine in that case? Because the 0 doesn't really matter, does it? Okay, good. So low d high minus high, which is 1 plus sine. What is the derivative of the lower function? Almost. 1 minus sine. Because there's an x, not a 1, okay? Just be careful that you see what's actually there, not what you want to see. It happens, I totally understand. Over x plus cosine x, the whole thing squared, right? Alrighty. Now here comes the simplifying. X cosine x plus cosine squared x, do you agree with that? Minus parentheses, I'm gonna get 1 minus sine squared x. Do you buy that?
Yeah.
Okay.
Isn't that just cosine squared x?
It is, yeah, X. That is not how I did it, but that is totally correct. Do you guys understand what he just pointed out? That 1 minus sine squared is cosine squared? So in that case, what would happen is that would cancel out completely, right? Here's what I didn't see that, so what I said, which is not necessarily, I think that way is better. X cosine x plus cosine squared x minus 1 plus sine squared x. If you didn't see that, do you see how this plus this is 1? And then the 1 minus the 1 makes 0? So either way, the simplified thing is x cosine x over x plus cosine x, the quantity squared. But Devin's way is definitely faster.
Sine squared plus cosine squared equals 1.
Yep, exactly. So cosine squared plus sine squared. If I add in one more step, x cosine x plus cosine squared x plus sine squared x minus that 1 over x plus. Does that make sense? Just change the order. And then cosine squared plus the sine squared is 1. And that 1 minus that 1 takes it out. So you can either notice that this is cosine squared and take it out right away. Or if you didn't see that, you're going to get a sine squared plus cosine squared together. No equals 1. Is that all right? Just ugly. Okay, how about the next one? For what values is the tangent horizontal? So you had a question like this in your quiz, except for it didn't involve a trig function, it involved a polynomial. So if the tangent's horizontal, what are you looking for?
0 slope.
Zero slope, where the derivative is 0. So what is the derivative of this function?
One plus
Mm-hmm.
2 cosine.
Mm-hmm. So you're solving 0 equals 1 plus 2 cosine x, or cosine x equals negative 1/2. Now, will this have infinite answers or one answer? Infinite answers. Does that make sense? Because versus cosine inverse of negative 1/2, that has one answer, right? This thing will have infinite answers. Okay. So in which quadrants is the cosine negative? 2 and I think it's 3.
Oops.
It's okay, because the cosine is the backwards part, right? And it's either this angle or that angle, which is either 2 pi thirds or 5 pi 6. So which one has the negative 1/2? 2 pi thirds. So x is 2 pi thirds. And to account for the going around the circle more than once, you say plus 2 pi n. And the other x would be down here, which is 4 pi thirds, right? Plus 2 pi n.
I thought you were gonna say that one didn't exist.
No, it does, yeah. There's that one as well. So it gets you to do a little bit more practice with like looking at the unit circle and figuring out, okay, which angle is it?
There's no real nice way that those things combine.
No, there's no way to combine those. I don't know of one, I don't think there is one. Unless they're straight across from each other, unless to go from one to the next, you add the same amount.
Yeah.
What's the case when you only find one of them?
That would be if it was something like you had tan x equals 1. And in that case, that happens here and here, and they're equidistant. So to get from one to the next, you add pi. This one to that one, you add pi.
I mean, when you're restricting domains.
Oh, well, that would be if the question itself said find cosine inverse of blah.
We'd have a negative.
You'd have to have the cosine inverse have to be present from the get-go, as opposed to something you kind of like add in or something like that. Okay, so find this derivative and figure out where the tangent is horizontal. So how about you do the first step of take the derivative? Like just apply the quotient rule and don't simplify. Just do that part. Just give it a shot. Because the simplifying is the grossest part. Did you just get your first step? Okay, next let's distribute. So you got secant x tan x minus secant x tan squared x plus secant cubed x over 1 minus tan x. Do you buy that much? It's not, because what you did there is you said the power distributes. It's not 1 minus tan squared, it's 1 minus 2 tan x plus tan squared. Does that make sense? So that's it's okay, it just, nope. Now, can you do anything to simplify the numerator? They all got a secant, right? So take out a secant. So you got tan x minus tan squared x plus secant squared x. And I don't expect you to know a whole lot of identities, but I do expect you to know the fact that sine squared x plus cosine squared x equals 1. This is your thought bubble. How do you get the one that involves secants? Divide by, how do you make secant? 1 over, so divide by cosine squared. And you get tangent squared x plus 1 equals secant squared x. So then what is, 1 is secant squared x minus tan squared x. So this is equal to 1. So that's secant x tan x, it's actually plus 1. So the trickiest thing here is recognizing when to use those identities. Does that make sense? If you see tangents and secants and they're both squared, maybe you can put them together and make them into a number. Do you buy that negative tan squared plus secant squared is 1? Yes? Okay. So we're going to solve where is this thing equal to 0. Yes? Was that a weight you needed help or a...
No, this is gonna be tricky.
It's actually not going to be that bad because the denominator doesn't matter because, does that make sense? Like we're not worried with that, where that's 0 is where it's undefined. So we're really solving 0 equals secant of x tan x plus 1. And then you're solving 0 equals secant of x, 0 equals tan x plus 1. And think about secant's picture. What did it look like approximately? First you graphed this sine function, right? No, secant was related to 1 over cosine. First you graphed this cosine function, right? Then you drew in these asymptotes, and you had this picture, right? Does that secant function ever equal 0? Yeah, so this, no, never happened. So not tricky. The secant function's range was like negative infinity to negative 1, 1 to infinity. 0 never comes out of it. Yeah. I multiplied by it and it went away. So I took this expression and I multiplied both sides by the denominator. 0 times the denominator means gone. Also, you think if this expression is equal to 0, it means it was 0 divided by some number. So the denominator doesn't matter as long as it's not 0. Yeah?
Isn't that 1 though, secant of x?
With secant of x, you could also think that this is 0 equals 1 over cosine of x, right? And if you try to solve that, you're going to get 0 equals 1, which is the more common thing you think of when you think no solution, right? So yeah, that's one other reason why. Can you solve 0 equals tan x plus 1 though? Are there going to be solutions for that? Tan x equals negative 1. And that means sine and cosine have opposite signs, but they're otherwise the same number, right? So is that at pi quarters? Nope. It's at 3 pi quarters and at 7 pi quarters. And that's the example of where you could write this as x equals 3 pi quarters plus n pi. Write it as 1 instead of 2 lists. Then you do 3 pi quarters plus 1 pi, that gives you 7 pi quarters. Is that okay? All right.
Could you possibly put like another pi over 4 plus n quarters?
Say that again?
And negative pi over 4 plus?
Oh yeah, you could have also put negative pi over 4 plus n pi. Yep. As long as the thing that you list is this or this in some form. Yeah, you could put any, you write that lots of different ways. If you think that your grader misses something like that, like after looking at the solutions, you say, oh, my answer is the same, just ask me and we'll fix it. Okay? Okay. And I promised that there'd be an example where there were 3 functions. Okay, so here's your example of 3. Product rule with 3 instead of 2. So you got 1, 2, 3. I'm gonna color code them. 1, 2, 3. Okay. So y prime will equal, so differentiate 1 at a time. In your first iteration, which one should you differentiate? X squared. So 2x, tan x is left alone, secant x is left alone. Plus, who gets differentiated next? Tan x. So x squared, secant squared, secant x. So this one. And on the last one, who gets differentiated? And secant's derivative was secant x tan x. Okay. All right, and so take out the greatest common factor. Is there a greatest common factor?
You pull a secant along.
And also I think an x, right?
Yeah.
So x, secant x, 2 tan x plus x secant squared x plus x tan squared x. I think that's good enough. Do you agree with that greatest common factor thing?
What's that?
Do you agree with the greatest common factor business that happened?
Oh, yeah.
And is the process of taking a derivative of three things multiplied together okay?
I'm good at this part. It's just when you have to know all the little secret rules.
Identities? Yeah. It is possible for this one that they might use the fact that secant squared is tan squared x plus 1. Like, maybe that, but I don't see how that'd be helpful. So it's a possibility, but I care more about, can you do something with like a 3 and take out greatest common factors? If we have to do tricks like that, I'll point them out. Okay?
If you did put tan squared, you still could pull a tan out.
No, and you could kind of combine some like terms and maybe, yeah, I don't think it's actually gonna do anything. Like, it occurred to me that you could, but I don't think it's gonna be helpful.
I agree.
So,
I don't
yeah.
think that's ever helpful.
Well, it is actually occasionally trying to solve things equal to 0, and you have to like so it actually is helpful sometimes. So, it just depends on the situation. All right. Okay, so if you want to find an equation of a tangent line, what do you have to find? You've got the point. What do you need to get? The slope. And what do you use to find the slope? The derivative, with the number 0 plugged in. So first step is find derivative, right? Okay. So y prime is, so quotient rule this, low. What's the derivative of the high function? 0. Low d high minus high. Derivative of the lower function is cosine x minus sine x. Spectacular. all over log squared, sine x plus cosine x squared. So y prime is negative cosine x plus sine x over sine x plus cosine x, the whole thing squared. Do you agree with that?
What's that?
Do you agree with that? Okay.
I was just wondering if you pulled a negative out.
You could, that would be fine as well. I'm just gonna leave it in because I think you'll make fewer mistakes that way, but it would work the other way as long as you are good at keeping track of stuff. So to find the slope, what do you plug in for x? 0. So you got negative cosine 0 plus sine 0 over sine 0 plus cosine 0. One of these is 1, one of these is 0. Which one's 1? Cosine. So you got negative 1 plus 0 over 0 plus 1 squared. I think that's just negative 1. You buy? Okay. So then get the equation of the line. Y minus y1 equals mx minus x1. So what's that? Y minus 1 equals negative 1x minus 0. Or if you get it in slope intersect form, it's negative x plus 1. Man. Is that all right? Okay.
I like the last one.
Yeah. Yeah, the last part is just algebra, right? But the point is that derivative gets slope of tangent line. So find derivative gets slope of tangent line. And also, like, if I'm grading this question, if you get the, like if it's 2 parts and you get the derivative wrong, but you do the slope correctly, I'll still give you full credit for the equation of the line part because you knew how to use the derivative and do it. Does that make sense? Okay. The next thing is a crazy question. Find the 51st derivative of sine. Do you think I'm going to ask you to really do 51 derivatives? Really? You think so? That'd be that evil? No. Rachel's like nodding her head. No, 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 no. There is going to be a pattern here. So we'll predict what the 51st derivative is once you find the first 5. Okay? I swear. So
Should be.
the original function is sine. What is the first derivative? Cosine. What is the second derivative?
Negative sign.
Okay. What is the third derivative?
Negative sine cosine.
I think it's just negative cosine,
I'm getting scared, man.
right? Because sine's derivative is cosine, so it's, and then what is the fourth derivative?
Sign.
Sine. Oh, look. You're back where you started. So what's the fifth derivative going to be? Sixth,
Negative sine.
seventh,
Negative cosine.
there's that eighth back at sine, right? See, they go in, you have cycles of 4, okay? Does that make sense? And this is the, that's our pattern, right? Does that make sense?
We're back at the.
Yep, so we just keep going in cycles of 4. So if you take 51 divided by 4, that's 51, 4 goes in there how many times?
12.
12, so 1, okay, 12, yeah, 2, 8, how's the remainder? 3. So what that means is you go through this cycle of 4, 12 full times. Does that make sense? So 1, 2, 3, 4, all that whole thing, 12. And then you have 3 to go, and you go 1, 2, 3. End up in that category. So the 51st derivative is equal to negative sine. If this had come out to be 2, what category would you have been in?
Cosine.
Cosine. If it came to be
Wait, what's once you're at the 48th derivative, you're on,
Did I do it wrong? Hold on a second, yeah, I think I might be wrong.
Yeah.
Yeah, no. Let me just think for a second. Am I wrong? Oh, shit, I am. Wait, I just swore on camera. Crap. Twice. You're right. Once you're at 48, you're here. So that's 48. Yep. So this should actually be negative cosine. Oh, crap. Look at your notes, Beth. See what I mean by that? Yep. So this is third, 3 remainder, same category as third derivative.
Yeah.
Right, that's my bad. I usually, my problem is I usually don't list that one. I usually just leave the function alone and say, okay. So, there you go. What if your remainder would have been 0? Then what, you'd be just at sine. Okay. All right. What if I gave you e to the x and said find the 51st root of e to the x? It'd be e to the x, okay? And this thing where you find derivatives and look for patterns comes up again in calculus 2. But only with sort of simple things like sine, cosine, e to the x. So other things, the patterns are a little bit hard, are occasionally harder to see, but not always. So, okay. So last question, one applied, well, second to last question. A mass on a spring vibrates horizontally on a smooth surface. This is its equation of motion. The fact that it's x of t means that it's on like the x-axis, and the position is measured like relative to the origin, like positive x means forward from the origin, negative means backwards. T is at what time? So find the velocity at time t. Velocity is the derivative, yep. So x prime of t is the velocity, which is what? Is 8 cosine t. Yep, just 8 cosine t.
So the 8 is the thing where we just took that constant out of the,
8 is just take the constant out, ignore it, take the derivative of the sine,
put it back in.
put it back in. Exactly. Yep. You could use the product rule, but you're going to get one of those things being 0. And it'll take you more time. So like when I did like my test to make sure it's not long enough, I'm going to check. I'll be doing the question like as if you know that. Does that make sense? Yeah, constants, leave them alone, differentiate sign. Okay. Find the position and the velocity at 2 pi thirds. So how do you find the position?
Plug in 2 pi thirds to the original function.
X of 2 pi thirds. So that's 8 sine of 2 pi thirds. And at 2 pi thirds, what's the sine? Root 3 over 2. So that's 4 root 3, and it is measured in centimeters. So if you're on a horizontal surface and you've got the origin in the middle, is this thing to the right of the origin or to the left? To the right, so it's positive. I think it's on a number line, it's going side to side.
What's that?
It's on a number line, like there's the origin, there's 0. It's going side to side. It's kind of going back and forth. Yes?
Won't you plug the 2 pi thirds into the trig?
To find the velocity, you would. Because there were 2 questions, to find the position and the velocity. So position is original, velocity is derivative. So velocity is x prime of 2 pi thirds, and x prime was 8 cosine t, right? This is 8 cosine of 2 pi thirds. So that's 8 times, what is cosine of 2 pi thirds?
No, it's
Negative 1/2, I believe. Yeah? Okay. So that's negative 4, and what's its units? Centimeters per second, yep, that's right. Okay. So you found the position, you found the velocity. Yes?
You said the direction's moving back and forth.
Yes.
That's not a direction. I mean,
Why not?
you have to pick one. If we're over here on that negative cosine side, should it be moving to the left?
That's what I'm saying, yeah. What I'm
said
saying
right,
is,
go back.
this thing is oscillating and going forwards and backwards, like just in general. And when you are at 2 pi thirds, you are 4 pi thirds from the center to the right. Because the velocity is negative, what direction are you moving at that time? I think that you're just answering the next question. The
So
particle
which
is,
direction are we moving?
yeah, is it moving to the left or to the right?
I would say that.
You're right, moving to the left.
Oh, okay. No, with your double arrows up there, I thought you were saying we're moving both ways.
No, not at one time.
Okay.
No, my double arrows just mean it goes that way and it goes forwards and backwards and it goes back and forth. It's not, I'm not trying to say it goes forwards and then back.
Okay.
No. So it's moving to the left because why? Because the velocity is negative. And the negativity just means backwards. And in the case of side to side, backwards means left. If this particle is moving on the y-axis, it'd be down. Okay. Ready for the last one? Ready for the last one?
Yes.
Oh, you